Hello.
Hi, how are you?
All right. How are you?
I'm good.
Good morning.
Good morning. All right. Let's get started. There's Lalith and Vidhi and Morgan. So, who wants to give their update
Yeah,
first?
Hello.
Hi. How are you?
Hi. Good. So I had a small discussion with Mehul a couple of days back ago. So I have currently worked on, in the last week I discussed that I have developed a few networks, and I have used certain models, right? So this week I mostly focused on, how do we have to approach and all. So for that, I took some insights from Mehul, and I approached him. So he has given me some, overview of like how we could move further and all. So maybe I will give some, I'll just share my screen. Just give me a second. Yeah. So last week I discussed that I have developed this, hypergraph convolutional network where it takes both the information of a lineage tree and also the spatial locations of it. So from that, what we discussed was, so it's good to use contrastive loss function. So while we are training, so we want to acquire some good features which are relevant to, so each time step when we are designing our own hypergraph. So what we wanted to understand is what could be the next time step, and doing so, we wanted to see that, okay, in the next time step, we are going to do this, and it should get aligned with the the values that were in the previous. So suppose we take the lineage tree, it has an information of traversing from like A, then to B, then A, B, P. So this tract should be observed, and this should be acquired by the network and each and individual neuron. In order to do so, we thought that contrastive loss could actually help in order to understand the network dynamics. So doing this approach will help us to understand the what is the topology that is there. During the evolution process. So what is the topology that is actually found that can be understood? So how, and I actually discussed with him, and we had some thoughts. But what I wanted to say that is, uh, probably in the next meeting, I'll bring up some nice presentation where I can show that. How this mathematically helps us to understand the, I mean, like, uh, the topology of the network that it has. So in the last meeting, Jayadratha has shown that from one point, then it moves and it grows slowly, right? From one it divides into two, and two into further two, and that network. And so it has a certain topology. So this can be captured using whatever the, our hypergraphs, and training in this specific set of fashion. So this is not the best way of doing it, but this is one of the way which can be optimal. So what it does is, so basically it tries to learn two different views. So here Z1 I say is the view one, and Z2 is the view one or view two, and it tries to find out the similarity between these two views. View in the sense, I have a graph, and I randomly remove certain set of edges and remove certain set of nodes and give it to the network so that it will learn the dynamics of how actually it was attached. And then we have, the original labels, the labels in the sense, what is the next predictive outcome? In the T1, we have, in the time step one, we have a certain, XYZ coordinates, and the lineage tree, it has like certain patterns, right? So in the T plus one, what it could be the possible, so that we are trying to understand. So the labels are basically the next time steps. So here is the loss function where we trying to understand the similarity between the labels and also the I mean like the views. Sriram, and when we try to train this contrastive loss function, this is the data loader, and which we previously have written, and this is the training pipeline where we have a given input at a time step t. Then we have embeddings of h1 and h2. Here h1 is the hypergraph 1 and h2 is hypergraph 1. We say it views, and then we sequence that model, and then we train it in a certain fashion. And also we'll add some test pipeline too, whether to check whether it's not memorizing, but it's actually learning. So I didn't do much this week, but it was hard to accommodate that this could be a right fit for that. So this was my update, and probably in the next week I'll probably present my I mean like the flow why we have started at this, and how I have came till this point. Why did I choose this approach and why is it optimal? I'll come with nice visual, I mean like not just visualizations, but a presentation where that why is this more insightful. So
Okay.
so yeah.
That sounds great. Thanks for the update. So next week, what's your plan for this week coming up?
So next week I'll probably try to train this model and see how is the performance, as we have seen like two different variations of the neural network, and the third one is the hybrid one. So we'll try to experiment on the data and see that how is the structure of the manifold, how is it the hypergraphs is able to learn this every time steps, and during the time steps is there any relationship that we can acquire during this training pipeline? Are we able to get some information saying that there are certain type of cells which are grouped into the hyper edges? Okay, are we able to understand that information? Suppose I mean like our hyper edge anyway consists of the lineage and spatial information. So is it relying on the only I mean like saying that is it bringing all the motor neurons together? Is it bringing all the muscle cells together? Is it all bringing all these things together? I wanted to observe that. So what are the things that are actually aligning with the hyper edges is what I wanted to observe. So during this, I mean like doing this experimentation could actually help me understand that step. So that maybe I'll bring that in the next week.
All right, sounds good. Thank you. Look forward to seeing that. All right.
Thank you. Any
Yeah.
suggestions?
I mean, I think you're on the right track. Well, I mean, I guess we'll see when we start to get some performance data to see if it works well. But I mean, theoretically, it looks decent. I mean, I don't know. Can't really say anything yet. But yeah. So yeah, keep going and see what happens.
Sure.
This is
Thank
the
you.
right answer. Yeah. Let's see. So we have Vidhi or Jayadratha. I guess Vidhi's waiting for
Yeah,
Sarah. Okay.
it's fine. I mean, I don't know whether she's joining today because she usually texts, but it's fine. I think I can give her my update later. I'll start over here.
Okay.
So continuing with Sustain Hub. Right. So this was the timeline, and last week I spoke about how I've used multi-armed bandits, and I explained how the whole multi-armed bandits problem is similar to our problem, and how I've applied that in our Sustain Hub. So yeah, that was supposed to be for week 3 and week 4, but since I'm trying to keep a buffer for myself and I'm being ahead of the timeline, I started off with week 5 and week 4 itself, which is with SARSA. So I was asked a question last week that what is the difference between Q learning and SARSA? So Q learning is basically an off-policy algorithm, and SARSA is on-policy. That means off-policy means that it learns from the best possible action that it has taken so far, and in SARSA it learns from the actions it has actually taken. So so I made a mistake while saying the best possible action, as in it actually learns from what it should have done rather than what it has done. But in Salsa, it learns from what it has actually done. So that's what the first 2 points are about. The third point is about exploration awareness. So Q learning is not very does not explore very much, but Salsa does, and that's why it is a good combination with multi-armed bandits. And yeah, the risk profile and the stability. And here we can see the difference between the two equations as well. That the equation of Q learning has a max over here. That means it learns from the best possible action. And Salsa has the same equation without max. So that's how the Q values keep getting updated in both of these. So why Salsa? Like, why have we chosen Salsa? Number one, because it is a non-policy learning. The non-policy learning matches our simulation goals, and it is more realistic in multi-agent settings. And it handles the exploration explicitly. That's why it's a good combination with multi-armed bandits, because multi-armed bandits are thoroughly based on exploration and exploitation. And it reduces the overconfidence in early learning. Right. So this is the equation, and like this is the equation that I've used. So QSA is the current Q value for the state as an action A. Alpha is the learning rate. That means how much it overrides the old information. R is the reward that it gets for each action that it takes. Gamma is the discount factor. And Q, S dash, and A dash are the Q values of the next state. That means if we are in the current state and we take some action, the next state and the action that we get are actually S dash and A dash. So yeah, this is again the same repetition. So in our case, the states are whether it solves a bug, it also solves a feature, or it solves a documentation. And the actions are whether it does the task or it skips the task. So when it does the task, there are further two possibilities. That the task will be done successfully, or it's going to be unsuccessful, or it can skip the task. So if it does the task and it's successful, it gets a reward of +1. If it does not do the task, if it does the task and it's unsuccessful, so it gets a reward of -1. And if it skips the task, it gets a reward 0. So this was the output. So when we start initially, like the maintainer will use multi-armed bandits and allocate tasks using exploration and exploitation. So here we can see that most of these contributors that come are unclassified, and based on what actions they complete, they get classified into what they are. This is when you run it for 10 steps. So like this is the output that you get after running for a few more steps. So we know that all of these agents have been assigned, or like they have been classified as some agents or the other. So now this is step 9, and this is what happens in step 10. They were all assigned some values. They were all assigned some tasks, and C5 chose to do the task and got a reward of +1. So it did the task. So before this was assigned, C5 actually has 63 successes and 16 failures. But if we see in step 10, it got a reward and it completed the task. And it has a ratio of 64 and 16. So we can clearly see how it has increased. Yeah. And also, like last week, as Sarah suggested, each of these agents, for what tasks they do, they get a positive reward. Like, for example, the contributor will get a +3 for bugs, but it will get a +1 for the other two tasks that are not supposed to do, and it'll get a -1 for not doing the task. And same for innovator and knowledge curator, just that they have +3 for the respective tasks that they're supposed to do. And this is what how it looks like once the Q values, like I have JSON files, JavaScript object notation that keeps storing the Q values. So after every action and after everything that they do, the Q values keep getting updated for what they have done. So over here it's negative because it kept on getting a negative reward for not doing those tasks. So based on positive and negative, these keep getting updated after each and every step. And yeah, I updated the README file accordingly, where I've explained a bit, like not explained, but I've just explained how we can run this simulation. And I had a blog for week 4. So now my plans for the next week are that I can probably add more agents and not be constrained to like 10 agents. and I can change the reward system a bit. Let's see which one works better. Yeah, and that's for like refining and optimizing.
All right. Thank you.
Yeah.
That looks good.
Do you have any questions?
No, and I see that we have a pull request that needs to be accepted. I'll go over that after the
Okay.
meeting. Yeah, but it looks good.
Okay. Oh yeah,
Uh,
and about the pull request, yeah,
okay.
I remember you had mentioned some time back that you want a vision board or something. So I'll create those pull requests. I can create one for multi-armed bandits and one for salsa, and then I can like the issues part, right? Like Sarah had done last year.
Okay.
Yeah, yeah, I'll do that. Okay.
All right.
Yeah. Thank you.
You're welcome. All right. So, Jayadratha, are you ready to give an update?
So last week we decided uh, like what we will do this week. So last week we decided we'll create a continuous time dynamic graph from this data. So what is the continuous time dynamic graph? What I have created is I have taken parent cell as my source node and daughter cell as my uh, destination node, and birth time as my time of entry. That is like I have divided, since each parent cell divided into only two cells, so I have divided each of these row into two different entry. So at time t is t equal to 0, there is two edges that is forming. One is between P0 and AB. So this is the parent cell and the daughter one, and P0 and P1, that is parent cell and daughter 2. Similarly, at birth time 17, I have created two cells, AB and ABA, and then AB and ABP. Like this way, I have created, and also have taken like each cell, since P0, AB, P1, I have taken these as a number. So if I have taken P0 as 0th cell, then AB as 1th cell, then P1 as 2, like this way. So total number of cells I have got is around something like 1,000, and this is the way like I have done, and also I have assigned P0, P1, AB, all of them some kind of node. Uh, uh, I mean node features, and also for a like for temporal age also, since there is an age between P0 and AB, I also created an age feature. But there is only one thing that is available here, that is parents location. So that is, I mean, yeah. So parents location. So I only use these to create both of them. So now if I go to the code is not very optimized now, but I have I created the dataset and run on one like the I run on one CTDG model and checked what is the results that are coming. So this is the dataset creation part. So initially I have seen existing dataset, how they have created, and like I have checked that, and then I tried this dataset, uh, like dataset creation, and I have taken 172 as the node or edge features, as previously other datasets they have used. So here what I have done is, uh, like as I already explained, uh, so I have taken here uh, like age features as parents XYZ, then daughters XYZ, and then birth time, and then the rest of the other features as I have padded to 172. Similarly, for node features, like 0 to 2, that is XYZ, parents XYZ, then 3 is the birth time, and then like other generation level that I have used. And this is how I have got total. So the total number of data point is here 642. So 642, from each one I get two data point. So 642 into 2 is like 1284. So that many is my source node and destination node, and T is the time when that thing that like cell division that happened, and message is like the age feature, and X is my source uh, source nodes, whatever is the source node. I mean number of total node 1203. Though I have not used this, I have taken this. So source nodes, uh, like what do you call it? Source node feature. This is the way I have like taken, and also I visualized those. So as I told, 0, 1, then 1, 2, 3. These are the source and destinations. This is how I have created, and now I have like there is a this TGN code was already available in the PyTorch geometric like PyG's example section. So I just have taken that and run on this dataset. And so what I have found is like I have ran for 25 number of epochs, and I got around 81% test AUC. So given given the like without optimized code, this is good enough, like 81%. If you see the other data set how it performed, so this is on random settings. So if we take TGN dataset, these are the different CTDG datasets that are available. TGN is the method, and like Wikipedia, Reddit, MOOC, Last.fm, and those things. So here, these on these datasets, Wikipedia, Reddit, it is getting really good results. But here, Enron and Last.fm, it is around 80%. So our like here we are getting AP and AUC similar to like what other on other data sets it has achieved, but there are a lot of things that can be optimized. Like I have just taken the position and the time as it is and appended to create the dataset. So one thing that is very naive approach that can be done is I can normalize those features. So that is the next week I'll do those things. One is like I'll normalize those features. Another thing is I I can take some kind of pre-trained model, some maybe language model, and I'll send it to it these uh, uh, like these locations and the time, and I'll ask it to give me back the embedding 172 dimension or some kind of dimension embedding, and it can give that. So one can be I have to check if on time series data if such pre-trained model is available. Otherwise, we can take like some language models that is like encoder type language model to like to get the uh, I mean 172 dimension input features. And also next I'll uh, like benchmark whatever they have done. They uh, for each dataset they ran on different models. So I'll try to see how other models are performing, which are good models, and then uh, if it works fine, then that is good. Otherwise, we can think of like if we can develop some new models that is good for these kind of data.
So you're going to be using a language model to get like embeddings and things like that. I mean, I
Yeah.
don't know. I'm not familiar with that kind of approach, but it sounds interesting.
Okay. Yeah. I was thinking like since I have to get two things. One is age features. So this is the parent P0 and this is the daughter AB. So there is at time t equal to 0, there is one age that is forming in between P0 and AB. So what can be the edge features that I can throw to the to this model, to these kind of models. So
Okay.
for that, I was thinking maybe I'll try some kind of encoder type model that has some world knowledge, and from there I can bring uh, like 172 dimension or some other dimension. Uh, some other dimension features.
Okay.
If we use those kind of thing, then generally the accuracy it increases.
So yeah, what is on the schedule for this week coming up?
For next week,
Yeah.
yeah, for next week, that is what I was thinking. Like I'll play with other some normalized features, and some kind of like one is normalized features, other is maybe I'll try with different encoder model. That is the second thing for creating the features, and for creating the edge and node features. And if that is done, once it is satisfactory, the results, I'll consult with you. If those looks good, then we can benchmark. Maybe like uh, we can once the data set is done, once the data set is decided, this is good enough, then we can compare with different models on the same data set. So this is like I have only used TGN model for on that data set. Then we can maybe try graph mixture, digiformer, those kind of existing models.
Okay. Yeah. So that paper you were showing, they were doing like graph analysis on different types of systems. So this is like
Yeah.
Wikipedia, Reddit, MOOC. Yeah, and then they have these different methods and they're benchmarking everything. The last one
Yeah.
is uh I can't read it, but it's basically the one you're referring to here. Dynamic graph learning
Yes.
or whatever. Yeah. Dynamic graph
Yes.
former.
This is
Okay.
yeah. Yeah. Dynamic graph format.
Okay. All right, yeah, I think that's good. That looks good. I don't have any more questions, so
Okay. Thanks.
thank you.
Thank you.
All right. All right, so thank you for your updates, Jayadratha, Lalith, and Vidhi. Um, Looking forward to updates next week. Next week we'll be not having a Friday meeting, but I will still expect updates in the Saturday meeting for Vidhi and the Monday Devoworm for Jayadratha and Lalith. So that would be the um, July 5th meeting for Vidhi and the July 7th meeting for Jaya and Lalith. And then the next week we'll go back to our regularly scheduled meeting, Friday meeting. I have some things in the chat. So Jess says, are there any professional development topics that someone would like to discuss today? So um, I'll turn things over to Jesse in a minute. He can talk about it. But if you want something for him to talk about something specifically, um, you can bring it up when he comes on line here. And Jaya, there was a discussion about this paper, or he was mentioning, okay, so Lalith asks, could you please share the paper which you're referring to? And then there's this open review paper. Is this the paper? And he says, yes. There's an archive paper. So Jaya, what would you like to say?
Yeah, I didn't get like you told something about uh, meeting date of the meeting. Yeah, can you please repeat?
Okay.
7th is for me. Yeah.
All right. Why don't we look at these two papers here? This is the open review paper. This is towards better dynamic graph learning, new architecture, unified library. So this is the paper. Is this the one you were showing the table? Yeah, this is where the one that he
Yes.
just showed with the different types of data sets. Surprised they don't have C. elegans connectome in here. It's usually the one that people like to benchmark against. But this is a lot of socio-technical networks, and so they're able to benchmark the method there. Be interesting to see how like biological networks fare in this approach. They're also I'll get to that in a minute. Okay, so that's this paper here, towards better dynamic graph learning. Then the second paper, this is, I think, is this the same one or a different one? Oh, it's the same one. Okay. So it's an archive paper, and that archive link is here. I did want to mention that we do have last week's DevoWorm, and it's on YouTube. I went through some data sets that we have. We talked about the binary decomposition of the lineage tree. I talk a little bit about that data set. I talk about some other data sets that we have as well. And don't forget, if you want to benchmark things in C. elegans, the C. elegans connectome is always available to benchmark against. That's a well-defined network. And it actually has structure because you have different regions of the connectome, different circuits. We have some versions of that we work from. Some versions of that are available online. There's the gap junction, the connectome based on gap junctions. There's a connectome based on synapses. And the default connectome for C. elegans is the hermaphrodite, but you also have the male connectome as well, which is vary slightly in terms of its connectivity and the cells that are included. But basically, you have this connectome of 302 cells, and it might work. It might be useful as well. It's usually people will use it for different benchmarks because it's so well defined. So we have. So let me know what you want to do in terms of getting network data, benchmarking. And then, of course, there's all sorts of network data online. So you can benchmark these against non-biological data sets and data structures, but they're going to be much different in kind, and you might not get the same result that you would like from biological data sets. Not to mention, there are a lot of biological molecular data sets where people have analyzed protein-protein interactions and gene-gene interactions, but those again are going to be different from like anatomy. So, Jayadratha, you had something you wanted to say?
Yes, yes. Yeah, definitely. As per the plan, I'll work on the connectome data. So two of the, like previously someone have worked on it, or you have sent me two of the links for those kind of data sets. And like now I'm trying to build a pipeline. Once it is done, then we can bring up all different kind of data set. Maybe we have to like modify something, but we'll do that, and then we'll benchmark on against each other.
Okay.
Is it fine?
Yeah.
Okay.
All right, sounds good. So, Jesse, are you ready to take the floor?
Hey, yeah, let me some extra noise here. Hold on a second. 1 second. All right. Can you hear me okay?
Yes.
There's a little background noise. Okay. Yeah, I mean, I don't have a whole lot today. I was I was fishing to see if anybody wanted me to talk about anything specifically. As far as general updates, it's been an extremely busy week for me. Now that I'm done with a bunch of traveling, I'm back in Boston and sorting out a lot of things here. I've been to a bunch of different events. As far as things that are relevant to this group and so are the summer cohort and our professional development talks, I think the thing that comes to my mind today is essentially last week we talked about the decision making, the process, and how decision making affects things from sort of a top down standpoint. And excuse me, I feel like this week, what's on my mind in this space is essentially, the thinking about the kind of projects that we get exposed to, and the kind of work that you want to do. A lot of times when you're just on the team where you're making something, you're making, I don't know, it's sort of, there's a very broad difference between when you get to almost like when the puzzle pieces are laid out on the table and you're tasked with assembling them according to a very specific design or outcome. Like in a lot of cases, our Google Summer project, Google Summer Code projects, you sort of, there's a theme, and then you all submitted some very nice proposals, and we're here working on them to build them out, and we have guidance about it, and that's great. Like you're kind of getting this sense of how do I, build onto this mostly existing project and go from there, and you're working, or you're kind of, what. I'm kind of saying the obvious thing here, but just to kind of point it out, like you're dialoguing with us and the community around how to push this specific thing forward, and so it's always this mixture of merging with the existing project and then kind of trying to get your sense of, you talk to the other mentors, you talk to the people that have worked on the project in the years past. You're trying to get this sense of, this sense of where is the project going, and how do you add to it? And then as the time with the Google Summer Code fades away, you'll be taking that experience and you'll be sorting out, how can I apply either the same actual tools, but then also the same strategies of understanding, there'll be sort of you're gaining experience in how to connect with what the, Bradley here is sort of the ultimate say of, not quite your boss perhaps, but the one evaluating at the highest level of whether or not you're succeeding in the goal, right? So how do I link with what Bradley needs to have happen, and then the people on the field who've been doing it, and then your individual contribution and the progress on your goal, and you're kind of getting this acclamation of moving everybody's expectations in the same direction, and it's very important to do, and that's why this program exists. And then as you continue to go into other spaces, your role in both like being a consumer or a creator of the direction of the project will change over time. Like you'll get more experience. You might be leading a project, seeing about it. You might become the mentor. You might become someone in Bradley's role where you're having to evaluate, of the possibility spaces that a project can go in, where can it go, and is this contributors working to that end, and how do you actually maintain the feedback loops about that? So I mean, I feel like I'm just having a very brief meta dialogue about the stuff we're already inherently doing, but sometimes it's important just to simply reconnect on that. I don't know if you want to say anything briefly about that, Bradley, before I mention one other thing, but I'll pause for comments if there's anything.
Yeah, I guess I guess what you're describing is sort of a gap between sort of expectations and expectation setting. And so like it's like you come into a project with a certain expectation on what you maybe have experienced. I know a lot of people who come into the group, they haven't really experienced anything like kind of what we do, or maybe their project experience is limited, and then they come here and they have this sort of the way we do things, and it's different from say like maybe a purely school setting or a purely corporate setting. And then so then the expectation is such that you aren't, you have additional things to think about, you have additional things to fit your project into, and then we give you the expectation setting. And this would be true in any organization. If you go to like corporation, a new corporate culture, or a new, if you're moving from like a corporate culture to academic culture, or vice versa, it's going to be different. And then the expectation setting has to happen, and then you eventually catch up, and then you can achieve what you want to do, perhaps.
Mm.
And then, of course, this feedback idea is sort of like, sort of a cybernetic feedback, where you have goals and you have this expectation setting, and then you try to fit your goals within that. And sometimes you're successful, and sometimes you're not. So I think that's really interesting. And Vidhi had a comment in the chat. She said, actually related to what Jess said, we do have this mentorship program in my university where I was a mentee last year and will be mentoring this year. And then Jess said, happy to hear or talk more about that. And then VD said, yeah, I can update about it tomorrow, or like on Slack. Yeah, I'd like to hear about that. Yeah.
Yeah. I'm trying to find a. Yeah, it's not. I'm trying to find a post. I had a sort of a bonus segue to this by an event that I did attend this week. Is my mic too loud, or is it okay?
It's okay.
Okay, good. I had an event today, or actually it was yesterday. It's called the Future Meditation, which is a little bit unrelated to all of this, but it was also about technology and innovation and a lot of cool things, and how, maybe mental health or well-being or mindfulness is sort of the popular term to do that. And just for a very brief plug for that. But what was interesting is that one of the I'll really briefly share my screen just to show it. What's interesting is that, What's interesting is that the one of the speakers was actually like on the far academic side of it and meditation side of things. It was he was a Buddhist, a Buddhist reverend and professor and a doctor from Harvard Divinity School in the space, like very, very, very deep in that space. And regardless of the religious content, there was a really nice discussion on essentially community-based pedagogy, and it a lot of ties to what we're doing here in terms of how, in certain communities or certain religions and in certain Buddhist traditions also, like, you'd have a mentor and a student, and you'd be very close, but then also the role of the community in creating these opportunities for the student to interface with like different points of view and different ways of growing and developing. And the sort of brief tie into what I said before was, as you're developing, Bradley kind of said, managing, coordinating expectations and how that shifts over time. And I think, some of it, it's sort of an interesting mix between this and another concept that I'll mention is a sort of, we periodically talk about expert writing, which is, expert writing is sort of adjacent to it's juxtaposed to sort of the conventional academic writing that we've all been exposed to in our mainstream education. And expert writing is more, it's not about realizing that you've kind of been, incentivized to write, to explain to people that already care about what you're thinking. And expert writing is saying, when you're talking to the public who isn't a teacher or a professor, you might have to have a different point of view in how you're arranging your arguments and how you're conveying meaning. And so my very loose analogy here, which I think I'll be saying more about soon, but just to kind of leave some food for thought for today before we move on to other topics, is in your education, and again, Google Summer of Code is kind of this bridging point, because we're not your direct teachers. We're all invested in you. We care, and that's not a bad thing. but we're kind of this staging scaffolding situation where yes, there's stuff on the line. There's money or credentials or CV pieces at play in your GitHub portfolio at play. But we're kind of this staging group of learning here how to communicate, how to manage expectations, and as you go more into a professional career or future work where you're trying to change the world, and that's sort of my personal biggest theme lately is like, how do we actually do things that have impact in the world, right? So as you're moving on into your career, continue to keep in mind how the process of updating these expectations and communicating with them will change on the environment that you're in, and also the role that your mentors or your supervisors or your colleagues, which is another differentiation to talk about maybe next time, but the role of these different sort of players in your life have in your ability to get information about the expectations, and then also how to actually relay them. So a little bit of a sort of a preview teaser, food for thought. I'm not saying a lot concrete here. I'm just doing a lot of idea framing for future discussions. But that's I'll leave it at that for this week. Unless anybody has any questions or further comments, just sort of yeah. Okay, I saw this other comment here too. But anything else, please go ahead, and then I'll look at Jay's comment. Jay said, "Can Jess, Bradley, others take session about technical presentation end to end, from acquiring materials to delivering towards a balanced audience?" Yeah, someone who is an expert in the domain to someone who's not of it. I think that's a very good topic. Unless that I'm. Anytime people have suggestions for things to talk about, because now we can think about that next week and have a nice discussion about that specifically. I think that's very important. I don't know if you want to immediately say anything about that, Bradley. I have one follow-up comment for that.
No, I mean, actually, I'd like to see. I'd like us to kind of do what we usually do every year for Summer of Code, is to do like kind of a presentation at the beginning and a presentation at the end of the uh, period. So you take stock of like where you're starting and then where you're finishing. So like, the starting point is of course your proposal, and in that case you're kind of a novice because you don't know, what you're actually going to do. You kind of know what you're going to do, the best plans for what you're going to do, but you also have this experience that you build on, and then you have this finished product. So it's going to look different from the original presentation. So that's something I usually try to do. And I think it's useful because you can then take stock of what you've done. Because a lot of times you do the stuff and then you get the finished product and you don't really think about it in terms of like, what did you learn?
Yeah.
What's different,
Sorry. We have one like ultra, like this is like going from. I appreciate that comment because it makes it a very easy way to go from kind of, I don't know, big theoretical concepts to that's sort of concrete. And now like this is directly from work experience that I've had, particularly in when I was working with a team that was building both, basically trying to coordinate the development of software and hardware to make a new product and a new sort of like interrelated product between a device and the software to connect the device to other databases and existing systems, right? And the amount of like you could say deviation, or you could say evolution from the original to the end of that process. Like it could kind of be, it almost is alarming to look at it in one sense. It's just like the way, like the inherency of the change and the I don't know if I don't really feel like calling them soft skills, but I guess that's what might be an easy way to say it. But like the soft skill of tracking and updating what you have your manager, your supervisor telling you what to do, and ideally it's good, but like learning how to ride the wave of everybody's perspective evolving on where to go next. Where it's always a bit about what's the next step to take, but then learning how to coordinate or uh, discuss the assumptions effectively with the people evaluating you, and then also as you get more experience or the more direct leadership yourself, how are you communicating those evolving ideas to the rest of your team too? Like it's a literacy that we're developing here, and it's not always easy to talk about, but we're working to that end. So yeah, that's great stuff. And then definitely for the comment in the chat, we often hear about the five levels, or like explain it to a toddler or a high school student or a grad student or undergraduate or an expert. Like that's a nice way to think about it. But like, how do you do that? Yeah, that's a great topic we can talk about in depth, because the key thing is essentially your audience, but then understanding what you can practice in a general sense is the sort of like in your mind, even if it's like 2 or 3 very basic differentiations of like how much depth and context are you assuming the other person has, and you can think high, medium, or low, and that could help you with some of your communications. But then yeah, like definitely it's kind of, and this ties into what I was saying about the expert writing thing, because what that points out is it's about changing the minds or addressing what other people think, as opposed to just explaining whatever your particular thoughts are. And it's a very different perspective on that. So more about that next week. Appreciate the comment. And always, if you have any other ones, please put them in Slack for us to focus on and prepare some things. But I look forward to that talk next time.
Very good, Jesse. Thank you. Yeah, we'll have to kind of work this out. I know Jesse wants to do sort of like this podcast series for Joe Pro and for his um, Substack that he does. So we'll see.
Yes.
I don't know if you wanted me to prepare anything for that, or if we're going to do like an interview at some point.
No. I respond a bit in Slack about that. Essentially, no. But I'm basically going to. I'm essentially hosting some interviews, and it may be a podcast or whatever it will be. And like this is one of the topics. Well, everything we talked about today, from the expectation changes to the question about explaining, to the question about how decision making affects stuff. Just those, I want to have a little more structured discussion about them. And so I invite Bradley and Morgan, and even other folks can also talk too, because we have experience. Like, one of the things I really want to do ultimately long term is capture. A lot of times, advice is only at one level, and a lot of what I'm doing with like from here to there. A very very brief plug for that, but like part of what I really am excited about doing is whoops, I just pressed the wrong button. Sorry. What I'm excited about doing here is having the 3 different groups together, and I'm just kind of making an arbitrary adjustment, but you have like these senior leadership the project or team managers, and then your early career people, or the people working directly on the team, and I find there's not a lot of like great ways of, a lot of advice is only for one of those things, and I don't think everybody needs to be, not everybody needs to be a CEO. Like there's very important reasons why the person in this group maybe doesn't have the same problem as the person in this group, and vice versa. Like there's that's fine, but holistically, it's sort of like getting the full stack of the leadership, the direction where things are going. Obviously, I think this isn't really a spoiler, but I'm really interested in getting people who are doing innovation and technology thinking from the actual generative process itself. Where are you going with certain things? Thus the name from here to there. But I'm trying to get different perspectives more literate in cross communicating across the divides here, so it can be a little bit more coherent in that space. So more about that next time. But yes, very much. Some of the discussion series that Bradley alluded to will be a little more intentional topics on those things. And Bradley and perhaps Morgan are certain experience levels, but for those that want to have certain conversations about what it's like as an early career person navigating this, I want to talk to that about that too and center that more than it has been. So yes, sure.
Okay. Thank you. Yeah, thank you for your discussion here. And it was like Jayadratha said thank you as well. So, yeah. All right, so I guess we'll finish up here. We'll finish up with some on something called hybrid open source. I found a couple of articles on this. Um, so there's this issue of open source versus closed source. So there's this sort of debate in open source software or in software development about whether you should make your software open or closed. And the sort of the default historically for commercial software has been closed or proprietary. Famously, Microsoft was a purveyor of uh, proprietary software to the extent that they were really paranoid about people making copies on floppy disks and exchanging them with their colleagues. And they were very active in preventing people from doing that. There are a lot of other proprietary software platforms that require keys or other things, and um, they're very paranoid about people making copies and accessing it without payment. So there's that history, but there's also this history of open source, of when you have software developed by teams of people where maybe 20 or 30 people in the world are interested in the software that you're building. So, you might be doing some sort of scientific software project where the number of people who really need to or want to use it is very small. So in those cases, it makes absolute sense to open things up, share resources, and have as many people kind of contributing to updating it as possible, because there's just no model for making it profitable anyways. And this is an article from, I don't know, Tag Vault. And this is open source versus closed source. So these are two competing software philosophies. And so open source software, of course, allows users to access and modify the source code, while closed source software keeps the code proprietary. And so the key takeaways here is that open source software encourages collaboration and customization. Closed source software provides dedicated support and proprietary features. Open source software can be as commercial as closed source software, and that's true. Just because, like I mentioned, it makes sense to do, if you have a very small niche market, it makes sense to be open source because you can't make a profit. You can also indeed make a profit off of open source software. So there are a lot of foundations that sponsor open source software that are profitable. And so, they can do things such as sell services, where they can sell different combinations of software. So, the main kernel is open and free, which is FOSS, which is free and open source software. But then you can take components of the kernel and turn them into things like enterprise versions of whatever software it is, or some sort of other specialized application. And so there are ways to make money at open source, but the idea is that at some point you have certain aspects of the project that are open. And this, of course, leads us to the hybrid model, which is where you open up parts of the project, you close other parts of the project, and you use that as part of a commercial strategy, or sometimes use it as a security strategy, because security considerations often differ between open source and closed source software. Not to say that closed source software is necessarily superior in terms of security, but open source software projects can suffer from security flaws, which closed source software maybe don't. And sometimes those are related to people contributing to the project, contributing malicious code, if there's not sufficient maintenance to the project, or if you have a problem like a worm or a virus that if you have small open source projects, they become overwhelmed by the technical challenge of fixing it and patching it. They don't have that, and that's of course like the log4j virus that was happening several years ago. And so, again, closed source software suffers from security problems too a lot of the time. But the assumption is that if it's proprietary, it's run by a large organization and they have the resources to fix it. So, I mean, these are considerations you need to take into account when you pick a strategy for how to open up or close your software. And a lot of times a hybrid strategy will allow you to, maybe protect really vital components of the software, but then open up other parts of the software that have less of a security risk. In any case, that's up to the organization. And then cost effectiveness varies based on implementation and support requirements. So, what is it cost effective to do? Is it cost effective to be open source, like in the case of like the scientific software, or is it cost effective to be closed source? And then, of course, you could think about this in terms of being too closed source. So, there are a lot of companies that are proprietary, maybe to a fault, meaning that you make it so hard to use the software as a proprietary piece of software that people question whether they really want to use it. And so in some cases, we can think of like Adobe, or, there are other software where you need to have a key in your machine. And then, you need to pay a certain fee to keep using the software. So sometimes the fees become onerous for an organization. So if I have a small company and I don't have a lot of budget for technology and I need to use Adobe, and then they charge me like fees, and I can't keep up with those fees, and it becomes a problem. If I'm in a large corporation, I can probably absorb that cost, but if I'm in a smaller organization, I can't. So I look for an open source alternative, and you can do the rest. It's interesting though that we think about open source and closed source software and security issues, and we say, well, one standard we could look to was different governments around the world. What are they using for their software, for their different agencies and things like that? So a lot of times, we might expect governments to use sort of the highest security software because they don't want people breaching data, they don't want people breaching their national security secrets and so forth. And as it turns out, there's some countries that adopt closed source software and even legacy software. And there are other governments that have embraced open source software. I think the Netherlands recently did this, and Brazil's been using open source software for a while in their government. So there are different ways that this can be implemented in organizations. Okay, so then this is an image here of development of the Linux kernel. So this is the history of the Unix kernel. I'm sorry. And this goes from 1969, I believe, to, I guess, 2013. So we start off with Unix. We start off with sort of the undefined PDP-7 operating system. We get versions 1 through 6 of Linux, or Unix, I'm sorry. We get them branching off to BSD and new versions of Unix. And then we get Sun OS. And notice the color code here. So green is open source. I don't know what this color is. Orange is mixed shared source. And then red is closed source. So it looks like at the beginning of Unix, we have this mixed source or this shared source. So it's not truly open source. And I guess one way it's truly open source is through licensing. So the licensing at that point wasn't like firmed up. We didn't have a good sense of how to license open source software, but also that you did have Unix coming out of large laboratories, and they had their own policies for how to publish software. So this is all Unix, which we kind of think of as open source. Universally, it's actually started out as mixed or shared source or hybrid source. And so we end up going down to SunOS, which is the first closed source version of Unix. Then we have Xenix, actually maybe Xenix was a little earlier, and that was closed source. And then Next Step, OpenStep, which was something Steve Jobs worked on, and that started in 1987, Next operating system, that was closed source. Then you get Mac OS X, which was the server version, which was closed source. Then interestingly, Mac OS X Darwin version was mixed source, which is interesting, but it has its roots in the Unix lineage. And then, of course, we have our open source or our green squares. So this is where we start to get BSD. So BSD started as mixed source to about version 4.3. And then after that, you start to get truly open source BSD. You get FreeBSD and NetBSD and OpenBSD. And the same happens with Linux, where you get the first version of Linux kernel, the one that we use today in 1991, and then that's open source. But we continue to also have closed source versions of the same root in Solaris and in HPUX. And then from Solaris, we get this Open Solaris that opens up around 2008. So you can see that there are different strategies for this, different ways that organizations have addressed open source and opening up the source of closed source. And it really serves a lot of the decisions made in those organizations, the products that they're making, and some of the needs that they have for security and other things. This is the second article here. This is from, I think, App Developer Magazine. And this is how you can benefit from a hybrid source model. So they talk a little bit about some of the pros and cons of open source software projects. And again, there are good things about open source and there are bad things about open source. But it really depends on your organizational goals and what you're doing in the organization. So what could be good in one organization could be bad in another. So this is Dr. William Bain, the founder and CEO of Scale Out Software. And he talks about how they use a hybrid model in their organization. So open source projects bring together large communities of developers who can drive widespread adoption of new software technology, create new features, and fix bugs at a very low cost. Large companies can subsidize those projects. So if large companies subsidize open source projects, they can remain open. Of course, there are intellectual property issues sometimes, but other than that, they have sort of the means to stay open. Companies usually have an interest in using projects open source software in their business activities, so they must use it as an incubator for their own organization. In a lot of open source projects, if you're dealing with something like a operating system kernel or some derivative of a large corporation, usually you have a staff of people and both a community and a development team that kind of interacts in many ways. Another drawback to open source projects is that by their nature, the development process encourages only incremental innovations, which is an interesting point because actually one of the arguments for open source is that it drives large scale innovations, and it depends on really how you do open source. So if you're if you're an organization and you're trying to find sort of new ideas and how to implement them, open source might be a way to do that. You can solicit ideas for new features and you can think outside the box. and the cost to that is somewhat low because you have, um, you can try new things without like committing them to the main production branch. But on the other hand, of course, yeah, it can sort of encourage incremental innovations. I think this is an interesting point, and I talk about it in my project management course. So this is something that I'm going to try to follow up on here. As the limitations of the original design concepts inevitably surface, some developers begin to rethink the core ideas. So really, if you think about a project that's open source, you're usually contributing maybe, incremental patches or something. And then eventually you begin to see the problems with the original design as it ages, or as you contribute new features or whatever. And then some developers begin to rethink the core ideas. So sometimes it can drive this sort of evolution of the product. Whereas in a corporation, you can do this too, but usually um, it's much more like, it's kind of like Microsoft where you have a timetable for producing new versions. People expect the new versions to not deviate wildly from the last version, and that's kind of the model. And there's a sort of organizational inertia that prevents rethinking core ideas. But in open source, you can do that. It can be difficult to do from within the project. So sometimes people fork the old project and have a new fork, and then try to implement new things. And then if those are successful, they end up being promoted into newer production versions. So you can do a lot of innovation at a low cost to the organization, which you may not be able to do with proprietary software. So there are a lot of things to think about here, and of course, this is just kind of how to open source your what you're doing in your company or in your organization. But there is this sort of connection between what do we open source and what do we keep proprietary, and what's that workflow look like. So we might want to have an arm of innovation that's open source, and then what we have closed source is sort of the finished version. So everything that happens in open source land is sort of, it's open, you can fork it. There's a lot of innovation going on. And then whatever the best stuff is from that, you pull the fork back and you incorporate it into your production branch, and you go ahead and you put that into the proprietary software. Now there's a lot of licensing, of course, that is involved in that, and a lot of human relations where people feel like they don't want to contribute to a commercial enterprise unless they're being sufficiently compensated. And so that's a problem. That's almost as much of a problem as the actual sort of sorting out the strategy for open source versus closed source. So that's kind of what I wanted to talk about. I just wanted to get that off my chest about those kind of strategies and how we think about software development. Right. All right. So, did we want to talk about anything else before we go today, or?
Just slight question. I think I've already asked this before. I know you have your materials for like the whole open source project management course.
Mm-hmm.
Is that course running currently, or that course be like happening again in like next term or next year or anything, or how does that work?
Yeah, well, I'm teaching it again in the fall, and I continually update it. So I've
Yes.
updated it.
Yeah. Okay. Cool.
Yeah.
Maybe that might be like a specific discussion. It's like, let's talk about that course, because
Yeah.
there's so much there, and even I forget how much is there. We talk about it all the time. So more about that later. But no,
Yeah.
that's a very good discussion. Thank you.
You're welcome. Okay, so the midterm evaluation. Yeah, let's talk about that before we go. So that's coming up in the next few weeks. So I'm pretty open on, like, I think all of you are going to pass the midterm evaluation. I will get a form from Google, and I have to fill it out. And I'll probably just give you suggestions for what I might expect in the next part of the program. So, I think you're all doing well. Um, we just need to like kind of walk through. So, we've started our projects. We're getting into the swing of the, implementation. We're not quite at implementation, but that's okay because we have to figure out what works. Now, the next part, of course, is implementation. And then after that, we're going to have, where you're going to have to prepare your projects. And that's going to involve documentation and, kind of putting out some demonstrations of what you have. And then, of course, finishing up, maybe creating a bunch of issues for if someone picks it up next time. So we know where we stand at the end of the program. So right now, I think we're doing well. I'll give some individual comments on projects. And then I guess they share the comments with you. But I don't think that's going to be a big deal. That's kind of like a formality from our perspective. Yeah, so that's good. Okay, thank you. See you. Well, not see you. Don't see you next week here. You'll be giving updates in the respective meetings. So Jayadratha and Lalith, I expect, that you can attend the 7th meeting on the 7th, the Devor meeting, and then Vidhi, the Saturday meeting, which you already usually attend. And so, and then if you can't make it for whatever reason, let me know. All right. Thank you. Take care.